Welcome to my YouTube channel. This is Nadeem and you are watching PLC Programming Tutorials. In today's session, we will do some exercise of PLC programming for beginners and we will try to make a program in the ladder logic for the pneumatic cylinder. But before starting, I would highly recommend you guys to please subscribe to this channel and press the bell icon for more upcoming video tutorials. In today's session, we will see how to program the PLC for the pneumatic cylinder. Let's discuss the setup for today's tutorial. We have a cylinder which is actuated by the pneumatic solenoid valve which is connected at the Q0.0 PLC output. Next, we have two reed switches to detect the position of the cylinder piston. Whenever the piston is at the back position, the back reed switch will send a signal to the I0.1 PLC input. Whenever the cylinder shaft moves forward and its piston reaches in front of the forward reed switch, the forward reed switch will send a signal at I0.2 input of the PLC. We have a selector switch connected at the I0.0 input of the PLC to start the process. Today's exercise is really simple. Whenever we turn on the start selector switch, the cylinder output Q0.0 should turn on and the cylinder will move forward. And as soon as the cylinder is fully extended and its piston is detected by the forward reed switch I0.2, the cylinder should wait here in this forward position for 4 seconds. And after 4 seconds, the cylinder should come back to the back position. As soon as the cylinder shaft comes back and its piston is detected by the back reed switch I0.1, the cylinder should again move forward and wait for the 4 seconds at that position. And this cycle of moving forward and backward with 4-second delay should repeat itself until we turn off the selector switch. So this is the exercise for today's tutorial. Now we will go to the Schematic Manager software and we will do some programming there. To start the timing, we will insert a network here by right clicking and it will add a network here. As we have discussed earlier that we want to turn on the cylinder once our start switch is on. So we will insert a normal open contact here and we can assign it the address of the start switch which is I0.0. Now whenever this start switch is on, we have to turn on internal memory bit which is M0.0. Okay, whenever our switch is on, it will turn on our start bit M0.0. Now we have to write a logic to turn on the cylinder output. To turn on the cylinder output, we will insert another network here and we will put an NO contact here and we can put it M0.0 which is our start bit. Next thing is that we have to turn on our cylinder output Q0.0. So we will insert a coil here and we can assign it Q0.0. So whenever start bit is on, it will turn on the cylinder. The next thing is that we have to latch on this cylinder. So to latch on this output Q0.0, we will insert a branch here and we can insert a NO contact and we will assign the same address Q0.0. Whenever this cylinder is on, this NO contact is closed and we will connect this line here and through this contact it will get held on. The next requirement of our program is that we want to turn on the Q0.0 cylinder output only when the cylinder piston is at home position. To confirm this one, we will insert here a NO contact and we will put I0.1 which is our back reed switch. So you can see that whenever start bit is on and the cylinder piston is at back position, it will hold on the cylinder. Now, the next thing is that we want to create a 4-second delay once the cylinder piston is at the forward reed switch position. So to make this logic, we have to insert another network, and we will put a start bit here, which is M0.0. The next thing is that we want to start the timer only when the Q0.0 output is on. So for this one, we will insert a NO contact and we will assign it Q0.0 output, which is our cylinder output. So start bit is on, cylinder is on, and the piston is at the forward position, which is I0.2 forward reed switch. So start bit is on, cylinder piston is at the forward reed switch position. So it will start a on delay timer. We will double click on it and we will add here a T1, and we will assign a preset time of 4 seconds, which is S5T hash 4S. 4S means 4-second delay. The next thing we will do is that we will insert a NC contact here and we will assign it T1. Okay. So what it will do, whenever this timer is over, this NC contact will get opened up and it will unlatch the Q0.0 cylinder output, and the cylinder piston will move backwards. And as soon as it is again detected by this I0.1 back reed switch, or start bit is already on, and it will again turn on the Q0.0 cylinder output, and the whole program cycle will start over again. Cylinder will move forward and its piston will be detected by I0.0 forward reed switch. Again the timer will start and its NC contact will open up, and our Q0.0 will again get a reset and turn off the cylinder output, and again it will come back and it will again start the cycle from this I0.0 back reed switch. So this whole cycle will continue like this until somebody comes and turn off the start push button. The next thing, we want to make sure that whenever we turn off this I0.0 switch, this cylinder output Q0.0 should be turned off. As you can see right now, this latch is only unlatching with the normal close contact of the T1 timer. So this means that even if we turn off this switch, this Q0.0 cylinder output will stay on. To turn off this output Q0.0, we will insert here the NO contact of the start switch, which is I0.0. So whenever we turn off this switch, this NO contact will also get opened up and it will latch off the output Q0.0. So now our program is ready. We will upload this one into the PLC and let's see how does it works. As you can see that as soon as I turn on the start switch I0.0, it will turn on the cylinder Q0.0, and once the cylinder reach the forward reed switch, it will start the T1 4-second timer. Once the 4 seconds are over, it will turn off the cylinder Q0.0 and again starts the cylinder to move forward. And once again the piston gets into the forward position, it will again reset the cylinder output. This process will continue until we turn off the start switch. As soon as we turn off the start switch, it will turn off the Q0.0 cylinder and reset all the timer and the output bits. So that's the end of the today's tutorial. I hope you like it. Do share, like, and subscribe to my channel. And if you want to download this project, the download link is in the description box. Till next time, take care and goodbye.